We are all familiar with the car in the modern world of transportation. It can get us from home to pretty much anywhere we want in our area. From school to work to the grocery store. And most of us know the gasoline-powered car quite well. You know, the one you always have to fill up at the gas station before a road trip. And a lot of us aren't just familiar with the gas model, but also electric or hybrid vehicle models too. But these two aren't just the only viable options for cars these days. There's a third type, one that blends both fuel and electricity. It uses what we call fuel cells to generate power. Instead of requiring gas like a traditional car, a fuel cell electric vehicle, or FCEV, simply requires two substances, a container of hydrogen gas and a consistent supply of oxygen gas, which can be obtained from exposure to air. Seems too good to be true, right? Well, let me explain how it works. In a traditional fuel cell, there are three parts in the interior. First, the anode, where oxidation or the loss of electrons occurs. Next, the cathode, where reduction or the gaining of electrons occurs. And finally, the proton exchange membrane, or the polymer electrolyte membrane, where the principal reaction takes place and byproducts are formed. Hydrogen gas is introduced to the anode, where it releases electrons and hydrogen cations. Oxygen gas is introduced to the cathode, using electrons to form oxygen anions. But where do these electrons that the oxygen molecules acquire come from? No, they aren't falling from the sky like raindrops, but instead, these electrons come from the oxidized hydrogen molecules. The two reactions in the cell are combined, and hydrogen and oxygen gas react to form H2O. And this water isn't contaminated at all. In fact, it's so pure that you could probably drink it and be just fine. Who needs Arrowhead or Crystal Geyser when you have fuel cells? But back to that source of energy. Where exactly does it come from? Well, the energy comes from the electrons freed from hydrogen. Before they reduce the oxygen gas, they first travel through a circuit attached to the cell, providing electricity and ultimately a source of energy from which the vehicle can be powered. Essentially, the electrons pull double duty, generating electricity and participating in the formation of water. They're being overworked and underpaid. Someone needs to give them a break. With the supply of energy from a fuel cell, you can power your car's electric motor and drive off into the sunset. Well, for about 300 miles, before you would have to refuel your car using hydrogen gas. But even that would just take a few minutes like a normal car. Not only is using a fuel cell electric vehicle as effective as using a regular gasoline-powered car, it's also a much more environmentally friendly option. This process only emits water and heat, instead of the toxic exhaust that can come from a traditional gas guzzler, and this can reduce greenhouse gas emissions by up to 90%. So, there you have it. Fuel cells and fuel cell-powered vehicles. An ideal alternative pathway for energy generation. You might not have learned how to drive one of those vehicles today, but now you know how they're powered.